So what about light that is in between horizontal and vertical? What if it's, tilted to the side? Well, if we have light that's tilted to the side, what's going to happen? And this is Malus's law. When light passes through a polarizer, only the component parallel to the polarization is transmitted. And this is a really important idea. So let's say we had light like this, where the electric field is oriented kind of in an angle. Well, only what's vertical is actually going to make it through. And so what will happen is only that vertical portion there will pass through, and that's all we get. And so what happens is if we have unpolarized light that's in all sorts of different directions, um, only what is vertical or within a vertical component is going to make it through. And so what happens is it reduces the intensity by 50% because half of that light is horizontal, half of that light has a component that's vertical. If we break up any part of this, we have a horizontal component, vertical component. On this one, right, a horizontal component, vertical component. And so only half of that light will make it through after the first polarizer. This is a good simulation to be able to view this. After light passes through the first polarizer, the intensity is a half. I encourage you to write this down and then or take a picture of it and then type it out in your web browser to be able to see this. And it's a great visual for this. So we have the light that passes through. In this case, our vertical polarizer, it's plane polarized. In the vertical direction, only half of the light made it through. Now it's all vertical. And, if it passes through another vertical polarizer, none of the light is cut out, right? And so if you think about it, you've got that plane polarized light. It passes through another polarizer, not a problem. It's just going to stay vertical. It's not going to cut out any of that light. So when light passes through a polarizer, only the component, again, parallel to the polarization axis is transmitted through. If the only incoming light is plane polarized, like this, let's say it's plane polarized, all the electric fields are lined up like this. Let's say, that we had a polarizer that polarized the light at an angle, and it's all lined up, right? And you have a vertical polarizer, let's say. Well, only the vertical components of each of these is going to make it through, right? You have the horizontal and then the vertical component. Only the vertical component is going to make it through. And so, yeah, it's going to cut out some of that light. And we can figure out exactly how much light is cut out. And we'll use this equation to do that. After it passes through, it's going to be plane polarized in the vertical direction now. So this equation helps us find that. We have the original intensity of the light, and we multiply that by cosine squared theta. And we can figure out, in this case here, if epsilon naught, which is the vector here, only, let's say we're going through a vertical polaroid, only the adjacent side, which is right here of this right triangle, only adjacent side is going to make it through. So the only adjacent side is going to make it through, and we can use this, if the light is already plane polarized, to figure out, how much is left. So, the question here is, let's say you had light like this, and it passes through a vertical polarizer. It's perfectly plane polarized vertical now, right? And it's going to have half the intensity. Then you can use Malus's law. If you have another polarizer at an angle, then it's going to be plane polarized at an angle. And then if this passes through a horizontal, some of the light's still going to make it through. This is a little bit, definitely different than this situation where the light comes through and it's vertically polarized, and then after it passes through and hits the horizontal polarizer, if it's vertical and it hits the horizontal, none of it's going to make it through at that point. Okay, so on this one, we have unpolarized light that is passing through two Polaroids, and one is vertical, the other one's 35 degrees from the vertical. And so we know that with the original light, the I0, I0 light, that's the original intensity of the light, is going to be cut in half. And that light is cut in half because, it's unpolarized, and then it passes through a polarizer, and, half of that light is cut out. And so at that point, it's vertically polarized, and it's going to pass through the second one. and it's at a angle of 35 degrees. Now, I'm going to work through this with you because it's easy to get this mixed up. In your calculator, what you're going to do is cosine of 35 first. Then you're going to multiply, then you're going to square that. And so it's important that you do cosine of 35 first, then square it, because if you square 35 and do the cosine of that, you're going to get something crazy. So then after we get that, that's going to come out to be 0.67101. So we take the original light, and that's multiplied by half. So half of it's gone, and then we multiply it by 0.67101, and only 33% is going to be remain of that original intensity of the light. And it's going to be plane polarized now at an angle, and that angle would be 35 degrees here. All right, so let's say we have a unpolarized light with an intensity 45 lux, and it's shining from a flashlight. It passes through a vertical polarized lens. If it passes through another lens that's 55 degrees from the vertical, what's the new intensity of light? And so I'm going to have you work through this one. Let's see if you can figure this one out on your own, and then we'll go from there. So go ahead and pause the clip and give this a try, and then when you're ready to check, you can hit play to continue. All right, so 45 lux. After it passes through the first lens, only half of it's going to remain. You're left with 22.5 lux. And then if it's vertical, and then it's 55 degrees from the vertical, it's going to cut out some of that light, and the final intensity of that light will only be 7.402 lux.